Hello, everybody.
Hi, Vedant.
Hi, Manif. How are you doing today?
Hello, hello.
Hi, Mr. Shobit. How's it going in Singapore?
It's going good, man. It's going good. A lot of work today.
You're taking over, right?
Sorry for visualization.
You said?
Is this for visualization?
Oh, no, it's just an intro EDA, just intro EDA with Python. I think it should have probably come before the other workshops because it's introductory.
Yeah. Wait, are you asking if I'm running it?
No, I'm just saying that it should have probably come before the others because we've had other workshops.
Oh, yeah.
Data wrangling, just because I didn't have time earlier in the week. So it's coming today. Hi, Simbo. Hi, Ahmed. Hi, Olamide. Should we shoot or? Is anybody planning? Is anybody with a laptop and planning to follow along? Maybe it can be a bit interactive since it's supposed to be introductory. Simbo, Manif.
Yes, Abhinav.
Are you working with your laptop and perhaps you want to follow along because it's a?
Yeah, I mean, yeah, I can follow definitely.
It's a beginner.
It's like,
okay.
Yeah.
Because it's a beginner class.
Okay, sure, definitely.
Or are you quite advanced?
Um, it's okay. I like to just learn again. Like maybe you might have another new methods, right?
Okay.
So
Okay.
yeah. But however, my place is the time is showing 12 a.m. So I might be mostly listening to your methods rather than trying from my side.
Trying to do it at the same time. Okay.
Yeah.
Where are you, man?
I'm from Malaysia.
Oh, okay.
You're Singapore. I think we are having the same timing, right?
Yeah, it's midnight right now.
Yeah. So Abhinav, shall we wait for others to join or a few more minutes, or you want to start?
I'm thinking that's what I'm thinking about, if we need to wait or not, or should we go ahead?
Okay. Maybe you can just put a one message in the meeting saying that the tutorial has started. You may join now, something like that, giving an alert.
Okay.
Yeah.
Okay. Start. Okay. So I'm trying to share my screen. Are you guys seeing anything?
Yes, we can see your screen.
Okay. So that's fine.
Okay.
So basically, right, this EDA class is a beginner class. So that means it should have happened before the class of yesterday that was done on data wrangling and data cleaning. And I think there's been some other visualization or EDA related workshops earlier. So we'll probably just run through what I have. I've tried to prepare some steps that I'm going to go through today so that I can make it as smooth and easy as possible. Because so from what I've studied, exploratory data analysis is about the initial investigations you will do when you get your data so that you can look at the patterns, try to find outliers, spot anomalies, or and try to validate your assumptions, because once you get a data set, of course, you probably start with some assumptions. Even if you're getting data about skills for employment, you probably have assumptions as to what the major skills are, or the locations where you have the majority of jobs. For instance, in Nigeria, we know that Lagos has the highest population and most jobs are here, and most of the skilled workers are probably here for most of the jobs. So that's an assumption you start with. So I could just jump into the steps I've prepared for this. So apparently, seems most of us are advanced. I don't need to explain what comments and libraries and packages are. So anyway, so I've just put some comments to help as we go ahead. So for me to start, I would just like to import pandas and pyplots and seaborn, because pandas is what we're going to use to load the data and do a bit of wrangling and exploration. Then pyplot is for plotting, for visualizations, and seaborn is for visualizations. So I'm working with Jupyter notebooks in case anybody doesn't have that level of awareness yet. So this data set is an online retail store that I pulled from the UCI machine learning repository. I just wanted to use something that is publicly available. I'm going to share this notebook when I'm done. So I've included the link here so that if you have the notebook, you can simply click and get the exact same thing I used. The data set is available on Excel, but when I was trying to load Excel took a bit of time and I didn't have all that energy. So I converted the data to CSV so that for this class, because we don't have so much time, I can load it to CSV. If you were a part of yesterday's data wrangling workshop that Olamide handled, you remember when he mentioned something about loading your data with index columns, specifying the index column that you want to load your data with. So for the purpose of this class, let me load without index and say data head, so that we can see what it looks like. So the data originally is just invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. So it's pretty much a simple data set, nothing so serious. In fact, I think I should just continue the class without using invoice number as an index. Let's use it like this. Let's just use it like this. So this is different from what I planned. The invoice numbers are not unique, so it's a good idea to continue like this. Doesn't matter. So one of the things you do when you are doing basic EDA is that you try to understand the data. You try to look at how many columns and how many rows you have, and that is achieved by using the shape method of your data frame. So you know that a data frame is just like an SQL table. So shape tells you the number of rows and the number of columns. And you can see already the number of columns, we've mentioned that before. And then you try to look at the head is just the first, starting from the top, how many rows down you want to see. So of course, the default is 5, but you can always choose to put 10 or 3 or 2 if you want to, right? Because I know I've done the default at the top here. So this is head, and we can look at tail, the bottom 5 rows, just like head. You can also specify what you want to see, but let's just take a look at the bottom 5. And we can see another country, France. We can see unit prices, customer ID, stock code, and so on. Now, if you are used to data types, you will notice that customer ID shouldn't be float. So there's customer ID is a unique identifier. It's like your driver's license ID, like the number. So there shouldn't be like a 0.0. It doesn't happen. So that's something that we'll look at later on as we go ahead. So in this method called .info lets you see info on your data, the columns, the types, just like it reminds me of also looking at SQL tables. There's a describe function in SQL that allows you to see things like this, depending on the language you're using in SQL. Then D types does a similar thing. So you see each column and the data type, object or integer or float. Sometimes you can have a date type. So you'll notice that this CSV file should have loaded invoice data as date. It loaded it as object. It should have loaded customer ID as string. It's loading as float. And because it's loading as float, that's why we have it appearing like this with the 0.0. Then sometimes I just want to see the columns. Assuming I had like 55 columns, everything won't have shown on just one screen. So two ways to do that is you can either modify Pandas settings or you can just do dot columns on your data frame and you get out the numbers of the columns. I mean, the details of each column, the names. Describe gives you summary statistics. So summary statistics is things like averages, quartiles, and so on. So you notice that it has only looked at numerical values so far, such as quantity, unit price. And unfortunately, for some reason, and the reason being that it's imported customer ID as float in numeric type, it is now giving you count and mean and standard deviation of customer ID. Customer ID shouldn't have all these things. The customer ID is not a number. It's an identifier. So it should have been imported as object. So down here, when we do the cleaning and manipulation, I'll try to convert customer ID to a string type. So far, does anybody have any question, or we're good so far? Right. Okay, pretty cool. Okay, so cleaning and manipulation is much like yesterday's workshop. There were some very good manipulation done yesterday, and I enjoyed the class. Lamide did well, so I picked up a few things also. And here, we're going to try to do some of the things I do when I get a data set. So when I get a data set, some of the things I do is to check for missing data, because we know that it's not every time, it's not all the time that you get data that everything is filled out. If you walk in anywhere, for instance, you know that there are people who, even if you ask customers to fill in their details by themselves, you ask them to put a phone number, somebody will fill his name and omit a phone number. Sometimes you say put a house address, you don't put a house address, and things of that nature. So that is that. So the way to check for missing data, you can simply do an aggregation to know how many columns have missing information. And we can see that description here has missing information, customer ID has missing information. So it is, at this stage as an analyst, you're going to ask yourself, why should there be a record for a sale and the customer ID was not specified? What's really going on? So is this, what sort of omission is that? So perhaps you could ask the sales manager or whoever to sort of clarify what kind of sales were those and so on. So the question I have for myself here is, what do the records of customer ID mean? Does it mean the sale was not recorded to a customer? There could be other questions you could try to answer. And so to filter a data frame, you try to set this, get this filter here. So this filter is saying, give me customer IDs that have no record or empty value. So from yesterday, remember that not NaN means not a number. So if we say customer ID.is now, we're saying, give me customer IDs where there's no records. And so if I filter my data frame with this, I check and I see that these are some of the records where customer ID is none. Reason why we don't know, we probably need to ask the owner of the store. And it's telling me that I have 135,000 rows with this situation. I can also remember that there's also descriptions that are empty. So we can do the same thing. So apply a filter in the same way. What are the records with empty descriptions? And you can see that all the descriptions we can see here, they are empty. We have about 1,400 of such descriptions. Then you could ask yourself, what are the unique stock codes that have no description? I've already gone ahead to do how many. So how many is 960? But if you didn't know how to do, if you didn't know how I arrived at the how many, you could simply do data.description.is now. Then, okay, so these are no descriptions, stock code, unique. So just gives us an array of the stock codes that are unique. If we didn't do the unique, then it's going to include some duplicates to get to the 1,400. If you remember, it's 1,454 here. So this is just a way, assuming some of the things they ask me at my job to do is, or I used to do, is something like, what's the unique count of customers who were affected by so and so. So as a data analyst, you'll get questions like that. So you might probably have to do it with SQL, but since you're working with Python here, depending on what you use, you do it here too. So I wanted to know how many countries have sales that have no descriptions. So the product manager or the sales manager could ask you, what are the countries where no descriptions were recorded? And I did this .value counts method is an aggregation. It essentially does a group by. So basically this is saying group by country, give me the counts. And it seems that it's only the United Kingdom that has no description. We can also do the same thing and say, how many countries have sales that have no customer ID? So this is our syntax. We say, we do another aggregation with value counts, and we can see that there's more countries here. Aya, Hong Kong, unspecified Switzerland. Does anybody know the name, what country this is? EIRE.
Not sure.
So, okay. So earlier I was, exactly, earlier I was just researching, and I found out it's an old, is it old? I don't think it's old. Well, maybe it's old. An E rather than an accented E. Irish orthography, so. Okay, so that's cool. So anyway, it's a UK store, so I guess they will probably call Ireland the way they used to call them in the past. But we who are from other countries, we don't know this, so we'll be asking ourselves the question. Okay, so I had a question now for myself. I said, assuming I don't want to keep records that have no description, I want to delete them. What do? I can filter out records with no description. Don't mind that I've pre-written all this code so I can make this class as smooth and as fast as possible. So I can maximize the 40 minutes or 45 minutes that the Zoom time allows. So if you are already familiar with the shape method, you remember that shape gives you the number of rows and the number of columns. So I can just access index 0 of shape to give me the number of rows. And I'm using that as a count because it's the count of records. So that's what I'm doing here. Give me the count of records of everything in this data frame, and give me the count of records for the things in this data frame, filtered by empty description. Description is null. And give me the count of everything filtered by description is not empty. So that's what I did here. So we have 541,000 records. Missing description is 1,400 records. And the records with no missing description is 540,000 records. So one simple way to delete records that are missing is not to say delete records that are missing, is to say return only records that exist. So because if you want to start saying you want to use .drop, maybe if you're not already used to it, you start making your code to throw up errors for you. And I don't like stressing myself with coding, so I like going straight to the point. So I use this method, remember, number of records without missing description. So I can simply say, I want to store a new, I want to create a new data frame where it is the old data frame, but only the records that have a description. So I can save this in this way. Then I can now do that aggregation to tell me how many records are empty. And I try this way. So if you will notice that all the descriptions, there's no one now that is empty. Everything is populated. We still have empty descriptions for customer ID. Is this one clear so far? My network is not down.
Yeah, I think it's clear.
Okay, it seemed like my network went off. I couldn't see anything else. Okay, all right, that's cool. Okay, so one question I was asking was, are there other cleaning activities that we could do? For instance, remember I was asking the question, what country is Aya? And we found out it was Ireland. So we can choose to say replace, replace everywhere you have Ireland, replace it with the actual long name so that anybody who sees it that's not from the UK or understands that description knows what to do. So I commented this out. Let me uncomment this. So my syntax here is simply saying return in this new data frame, return countries that are, return records where the country is higher. And that's this. So I could simply come back and say replace countries from higher and call it Ireland. And that is that column there. So if I really wanted to apply this, let me apply this completely and say data with clean descriptions country is equal to data with clean descriptions dot country dot country dot replace. Okay, then we can now say, so, right? Okay, so let's do that check again. Do I have it down here? Okay, I don't have that. So let's do this check again where we confirm that everybody that was supposed to be I is now Ireland. So if I were to run this again, you will find out that there's no record here. But if I were to search for Ireland completely, I'm pretty sure, let me just do head 2. Yeah, we're going to get some records. So right now, we have done that replace. So another thing we could do to clean up our data or to make modifications as we might like is to replace customer ID. You would remember that customer ID had a lot of null values. So it's just like saying that somebody bought an item, but somebody didn't, it was not somebody that bought it. So instead of leaving it as none, I want to change it to unknown or unidentified, that sort of thing. So remember that we did, okay, so let me do it here. Remember that D types is here. And for now, customer ID D type is float 64. So we are going to try to change this to string. So it's going to show up as object. And while I was preparing the class, I chose to do this method. There might be another method. Somebody might have a better method because I don't like this method, but it works. So what I'm doing here essentially is to say, for each customer ID, first of all, convert it to an integer so that it does not give us a decimal point, because as it is now, if you remember from the top, this is 25. If you remember from the top, it was showing us customer IDs with decimal points, right? And that was not normal. You don't have customer IDs don't come with decimal points. You're either customer 55 or that's it. It can't be 55.2 or 55.0. So there's nothing like that. So that's this method. So we apply this method, we change to integer to drop off the decimals, then we change that to a string. Then when you check D types again, recall that D types here is a float. If you check D types again, D types right now for customer ID, the data type is object. And what has happened is that while converting the string to object, I noticed that what it has done is instead of nan, not a number, it has changed it to this. This is what we have, this NA that is now a text. So if I run that, you'll find out that all the customer IDs that don't have numbers have turned into this form of this text that says NA. So what we are going to do is we're going to replace this NA and call it unidentified. And in order to do that, we'll just use this dot replace method once again, like we did it before. And this time around, I'll just go and use this parameter that says in place equals true. If you remember from yesterday's workshop, in place just acts like a save and records the modification you've done. The other method I did it as earlier was to do an assignment and say that this column is equal to this column. In place does the exact same thing essentially for you. So I can run this code. It does the replacement. So when I search in the data frame for where customer ID is NA, I don't find it anymore. It's empty. When I search in the data frame where customer ID is unidentified, I begin to find records once again. So we successfully changed every unidentified customer ID. The values, we've changed the values to actually say unidentified as a string. We can now run an aggregation to say, show me what's the count of each customer ID. And this is what we see. We see that there's a whole lot of unidentified customers. So this is probably something we need to discuss with the sales manager or whoever operates the store to know what kind of transactions these are. Maybe these are customers who don't create an account on the website, right? They just log in, buy without creating an account and proceed to checkout, and that's it. So that probably explains why you have a lot of unidentified. You don't have their names, you don't have anything apart from they came and they made a sale. I think that's plausible, right? Okay, so let's check. So right now, we don't have any more null values in any of the records. So is this okay for everybody so far?
Yes, yes.
Okay, cool. So once you've done some basic cleanup, right, of your data, and you've done some basic manipulations, right, you could now begin to look for relationships and try to get some more insights. Of course, you've already gotten some initial insights. Like one insight right now is that we are, as the analyst, I'm assuming that the reason why I have a lot of unidentified customers is that they are one-time customers without an account. So in fact, let me just add this. So unidentified customers, maybe customers. A purchase without creating an account. Yeah, so this could be validated with the sales manager or whoever is in charge of this. So I think this is something that I'm thinking of intuitively as I understand that websites have this feature. You can just buy and go without creating an account. So the sales manager can say yes. And then if the sales manager agrees that this is the reason, if this is found out to be true, you can replace all the unidentified and call them maybe one-time customer or something, right? Unidentified with maybe one-time something, or what in a brick and mortar shop we call them walk-in, right? Walk-in or equivalent identifier, right? So you can't use walk-in for an online store. So you can just call it, I don't know, browsing or something, or whatever you can call it. I don't know what nice names you could call it. So relationships. So I was saying that by the time you get to this stage, relationships, something you would need to look at is how does the data relate to one another, the columns, for instance. Wait, before I go too far, can I just ask, can anybody ask me a kind of, like, can we ask a kind of question that if you were a sales manager, what would you want to know from this data? What question can you ask? Because for instance, we've asked questions like, who are these unidentified, or what country comes with unidentified customers? So what other questions can a data analyst expect to receive from a sales, or can you as a sales manager ask if you wanted to get insights from your data?
What's the average price?
The average price. Okay. So I ran something for an average down here. So the data doesn't have price. It doesn't have it has the unit cost, but it doesn't have the price of what the customer bought. So that can be a calculated column if we wanted to do that. So let me do that. So let me calculate a column because of that. I don't think this correlation is something that is helping us right now. Let's calculate average sale value, right? So create a column as unit price times quantity. So it's data clean description is equal to distance. I hope I got it right. And price times data. Sale value. Very good name. Okay. So let's see what sale value looks like. Okay. So what does sale value contain? So remember here we did unit price times the quantity of products bought or products sold. And then let's add one more cell to say, so you said, what is the average price? Average price, should it be per sale? So let's say data with clean descriptions dot group by. This can be invoice. One sale can be denoted by the invoice number. So let's say group by invoice number dot, invoice number. And we are trying to calculate the average of the sale value. That's mean. Okay. So average per sale. But if you wanted to, I think your question was very broad and you just said average price. So I can easily just go back and say, give me the average price overall. Average sale value. Right. Okay. So using dot notation, so it will be the data frame dot the column dot mean to give us the average sale value. So one good thing we've seen from doing average price per sale is that there's some sales here that have negatives. So it's interesting as to why there will be some negative sales. Are these refunds? And we can see that the invoice numbers come with a C. So the analyst could now ask the sales manager, whoever is in charge, what did the negative sales mean? What are the is this how you are denoting the refunds with a C or cashback? Perhaps that's what this means, maybe cashback. The data set doesn't come with a lot of descriptions. So we are coming up with our questions as we're going ahead, right? So this is a good question, and that's something that people ask. So yeah, that's it. I think this answers it, right?
Yeah.
Okay, that's cool. Okay, so if this data set was like a richer data set with a lot of values, you would be able to do something more useful with this correlation. But I can't explain correlations for you. I'm not really a statistician. So the correlations essentially are telling you the relationship between columns so you can know which one has more effect on the other. Then, so if you had something that you could play around with correlations, I created something here with a heat map, and heat maps is just a visual way for to look at this correlation plot. There are some other plots you can look at. So just briefly before we end it, there are some other plots you can look at using Seaborn. So remember in the beginning, I imported Seaborn with SNS. So this allows you to create some plots that can help you understand the relationships with your data. I want to do pair plots because pair plot was pretty cool when I looked at it. So don't mind me jumping the cells a bit. I want to show you this before I just continue with doing a bit of aggregations. So let me do pair plot with a small sample. Unfortunately, pair plot takes a long time. So let me do it with a small sample of this data set. So if you had a pretty cool data set with a lot of information, you could use something like pair plot to see the relationship between multiple columns, right? So I loved pair plot as soon as I saw it. I just saw pair plot recently and I loved it. It just helped me quickly take a look at all I can see. So let's go back to some dirty stuff that we were doing earlier. So some other questions that we could ask ourselves or we could get asked as analysts are things like, can you tell us the total sales quantities by country? And here I've done a group by an aggregation. So I'm saying group by country, give me the total quantity. And here I'm just sorting values by descending order so that you can easily see who is the highest. And perhaps because the store is located in the UK, maybe that's why the United Kingdom has the highest sales, right? From what we can see here. And then Saudi Arabia has the lowest. So another question you could be asked is, give us the average now, not total. So what's the average quantity of sales for each country? And that is this. So Netherlands seems to have the highest on average, not total. And where's the UK? Okay, so the UK is down here. So you could easily say that this is probably because the UK has a larger number, so that sort of discounts it and gives them a lower average. So if you are doing some other more advanced thing and you're looking at the value of each person's sale and you want to quantify people by, value, then you could be considering the averages and not just the totals. So for this question I got earlier is a very valuable question. So now let me use that new column I created, this column called sale value, to now calculate the highest value, the country that gives the highest sales, total sales now, not just quantity of items sold. So let's go here and create a new cell where we're going to calculate the total sales value by country. So it's going to be the data frame grouped by country. Then give me sale value and give me totals. So let's do an order by. Okay, so now it's still UK. Okay, so sorry, let me convert it to integer before doing the order by. So that's what I'm doing here. So if it's by sales value, the United Kingdom has 8 million. Let's assume the currency is pounds. So 8 million pounds followed closely by Netherlands. So this already tells the business that this is where the majority of your sales income is coming from, or sales revenue, sorry, is coming from. And then the gap between them is actually quite large. So what more can we try to answer? We can try to answer sales quantity by dates, right? And before we do that, I want to convert the date type. If you remember that D types for dates was object, I just want to convert it to a date type. Yeah, before doing that. Okay, so let's do another aggregation. You might get asked, sales quantity by dates. Can we know the quantity for each day? And this is what we use to do that. So it's quite similar to the aggregations we've been doing before. Group by invoice date, the quantity, and give us the total. You could get asked what's the earliest date or the latest date in your data set, and this is this. Okay, you remember per plot. I showed you per plot earlier before jumping. So let me show you a simple bonus I found out sometime like 3 months ago. Pandas profiling. Pandas profiling is something I use this when I want to do some advanced analysis in the further, but I don't want to spend too much time. Like I sort of want to export the EDA results. I want to get a column by column EDA results and export it and give it to my product manager. So this is something I do sometimes. But if it's if I just want to quickly give them something to look at, then I can go further and then do my analysis. So you import this package, pandas profiling package, and then you can simply use this one line command to create a profiling report, and it just does your column by column analysis at once for you and gives it to you in an interactive format. So once this is done, you can see it's quite fast. If the data set was heavier, there are parameters you can adjust to do a fast check, so a fast analysis or a more detailed analysis as the case may be. So this just does my default analysis and renders it as HTML. So it's quite interactive. And then you can just go and do a column by column check, right? To see what you have. And it's just like doing your data frame.describe, but for each column, right? So it's quite cool. It's just a bonus I want to add here in case this is something that you work with. And there's a method that you can use to save to file, and you can just simply come and say to file and call it interactive profile report.html. And you save it and it goes to a file which you can open. In your browser. Okay, so I think I've done the 45 minutes I plan to do. Does anybody have a question at this stage for this introductory EDA class?
Nope.
Boss, okay. Okay. Okay, so this is it. So that's the interactive profile report that we did earlier.
Can you show me the HTML once more?
Yeah, that's this one, right? So that's this one.
Yeah.
So it's pretty cool. Just copy and paste it for the person who needs to see it, and he can, or they can take a look at it, column by column, and see what's there. And then you could now spend the other time building your ML model or doing deeper analysis. So that's what I do sometimes. Yeah, so that's it. Okay. Wow. Okay, so does anybody else have is there any other person who has a question to ask, or that's it? Safini?
No question. Yeah, go ahead.
Okay.
Can you share like the code to Slack or something?
Oh, definitely. Sure. I'll do that quickly once we're done.
Yeah.
Okay. So that's it from me then. So, prepare me. Okay. Okay. Since she's not easily available.
That was a good session, man. That was good.
Yeah. Thanks.
Thank you, Bina.
Yeah. Thanks a lot. Well, so thank you all for joining. That's a little from me on introduction to exploratory data analysis.
Yeah, thank you for the session. It was nice, simple and nice. Yeah.
Yeah. All right. Thank you.
Thank you so much.
All right then. Thanks. All right then. So I'll be ending the meeting then. Thanks, guys.
All right. Bye, guys.
Yeah. Bye.